All right, midterm problem. Midterm review problem number 3. So, we got this kid, steps off this tower, and he's swinging on this rope of length r. The initial angle with the vertical is theta. What else do we have? Mass m. Okay, first question. Using principle of conservation of energy, develop an expression. Hey, what does this mean? An expression. That means your answer is going to be non-numeric. Your answer is going to be in terms of variables. Okay, so we're finding the speed of the child at the lowest point. Okay, so conservation of energy. What type of energy? Well, first of all, if we're doing conservation of energy, we have to have a 0 point. Where's the best place to put your 0 point? At the lowest point in the problem, right there. So this line right here is h equals 0. That's our 0 point. So what type of energy does this kid start with? Potential of gravity, and that's it. And then at the lowest point, he has what? Kinetic. No potential because he's on the 0 point. So we go, okay, potential of gravity, initial. Oh, any non-conservative forces here. Remember that? Plus or minus any work non-conservative. What do we mean by a non-conservative force? Anything other than gravity or spring, okay? If doing work. Is there anything other than gravity or spring doing work as the kid swings down? Hey man, what about the tension in the rope? Is that doing work on him? Because why? At every single point, the tension is what? Perpendicular to the motion. So tension's not doing any work. So what's the only thing that does work as the kid swings down? Gravity. And gravity is conservative, so we don't have to worry about non-conservative here. The number one non-conservative force is friction. Any force that adds or removes mechanical energy is non-conservative. Okay, so equals kinetic final. All right, so we plug in the equations. Potential of gravity is mgh. Kinetic is 1/2 mv squared. The m's cancel out, so we're looking for the velocity, right? So velocity is going to be square root 2gh. Don't leave your answer like this, though, because look, what are we allowed to use? We're allowed to use g, r, and cosine theta. So what do we have to deal with here? We got to deal with this h. What could we say about h? Well, so go like this. So draw a line right here. So his h is this height here. So we need to find what that h is in terms of r and cosine theta. So here's how you do it. So what's this distance right in here? That distance right there, just focus on this triangle. What's that distance going to be? That's cosine theta r, right? What's the total distance from here down to there? What's the total distance? Well, isn't that just the length of the rope? Isn't that just r? Yeah. So what's h going to be? H, so h is this. H is going to be the total length of the rope minus that. So it's going to be r minus cosine theta r, right? That's what our h is. Which, by the way, that's going to be, you could factor out the r. You could say r 1 minus cosine theta, like that. So the answer is going to be square root 2g r 1 minus cosine theta when you take this h and plug it in there. Hey, now a nice thing about the midterm is it's partial credit. You get partial credit. So look, if you would have given this as the answer, would have you gotten 0? No, you would have gotten like maybe half credit or something, partial credit. So make sure you pay attention to the variables you can use. Yeah.
When you're doing work and you're like going step by step down, do you have to always have all the units like in your work?
Showing units in the work?
Yeah.
The College Board only takes points off for no units on the answer. It's better, I would recommend putting units in the work. That would be my recommendation, because the name of the game is make the AP grader, which on tomorrow's test, that's me. Make the grader think that you're the physics machine, that you are just like, you were born to do physics. So show units in your work. Okay, so number 2. So we now know velocity at the lowest point. So okay, number 2, the tension in the rope at the lowest point is 1.5 times the weight of the child. So let's do a free body diagram here. Well, we're solving for cosine theta. So do a free body diagram at the lowest point. So here's the kid at the lowest point, right? What are the forces on the kid? mg down, tension up. But what do they tell us about tension? It's 1.5 times the weight. So that's going to be 1.5 mg. Okay? All right, so now we sum the forces. And remember, center of the circle is up here. That's important. Why is the center important? For circular motion, center is important because it's always positive. Why is the center positive? Because what points to the center? The acceleration. Okay, so we're going to go 1.5 mg minus mg, right? Just sum the forces. Sum of the forces equals ma, but that's a centripetal because the kid is in a circular path. So centripetal equals v squared over r. So we can plug that in right there. So this becomes m v squared over r. And by the way, we know the velocity here. The velocity is square root 2gr 1 minus cosine theta, right? Hey, now look at, notice that the answer to 2 depends upon the answer to 1. So if you get number 1 wrong, you can't get number 2 right, but could you still get full credit? Yeah, you could get, you know what I'm saying? Number 2, the answer to number 2 depends on number 1. So if you get number 1 wrong, you're not going to get number 2 right, but you can still get full credit if you show the work. All right, so we're going to be taking this. This is the velocity at the lowest point, and we're going to be plugging that in right there. Okay, so let's simplify this. So here's our equation. So this is going to become 0.5 mg. So let's just call it mg over 2. This is going to be mg over 2, right? Equals m. This is going to just be 2gr 1 minus cosine theta. Like that over r. Okay, because the square root disappears because that's squared. All right, so the m's cancel, the g's cancel, and the r's cancel. This cleans up pretty nicely. Okay, so let me get some room. Okay, so coming up here, so what we have now is 1 equals, so cross multiply here, that's going to be 2 times 2 is 4. 4 times 1 minus cosine theta. So let's see, distribute that. So this is going to be 1 equals 4 minus 4 cosine theta. So then rearranging, that's going to be 4 cosine theta equals 3. So cosine theta is 3/4, or 0.75, which is the answer.